Today we will be solving February-March 2022, paper 12, AS and A-level mathematics. All right, so I know that the November A-levels are coming up, so I decided to start a playlist walking through and solving past papers to help out people. All right, let's have a look at question 1. Question 1 states, a curve with the equation y equals to f of x is such that f of f prime x equals to this. And then they're saying it is given that f of 8 equals to 5. So this is an important piece of information. And the question says, find f of x. All right, so how do we approach this question? So we have f prime x. That's basically the derivative of f of x. So we know that dy dx of f of x equals to f prime x. So now we need to perform the reverse operation. So what is the reverse operation of derivating? That's integrating. So we need to integrate f prime x with respect to x, and that's how we get f of x. All right, so what will actually happen when we when we integrate f prime x? So we will integrate what's given, and then at the end, we're going to have a constant plus c, because when we derivate, the constant just disappears. So we can't be sure what is that constant. But in order to find that constant, we're given that f of 8 equals to 5. All right, so step 1. Step 1 is integrating f prime x to get f of x. All right, let's integrate. We have to find the integral of 2x to the power negative 1 over 3, and then minus x to the power 1 over 3 with respect to x. Okay, we need to remember our rules for integrating. So we increment the power, so we add 1 to the power, and then we divide by the new power. So what is negative 1 over 3 plus 1? Well, that's just going to be 2 over 3. So we have 2x 2 over 3, and now we divide by the new power. So we divide by 2 over 3. All right, let's do the same thing. So what's 1 over 3 plus 1? That's 4 over 3. So x to the power 4 over 3 divided by 4 over 3. And then we have plus c. So we should never forget the plus c. All right, let's simplify things. So 2 divided by 2 over 3 is just going to be 3x to the power 2 over 3. And then this is going to be 3x to the power 4 over 3 over 4. And then we have plus c. All right, that's step 1. Let's just highlight what we achieved from step 1 so it's clear. All right, that was step 1. Now let's do step 2. So step 2 is plug in x equals to 8 to find c. All right, let's do this. So we're given that f of 8 equals to 5. Okay, so it's going to be 3, 8 raised to the power 2 over 3, minus 3, 8 raised to the power 4 over 3 over 4, plus c equals to 5. All right, now let's plug in the values into our calculator and simplify things down. So 8 to the power 2 over 3 multiplied by 3 gives us 12. And then 8 to the power 4 over 3 multiplied by 0.75, that also gives us 12. So 12 minus 12 plus c equals 5, which gives us c equals to 5. Now, let's write our final answer. So our final answer is going to be 3x to the power 2 over 3 minus 3x 4 over 3 over 4 plus 5. And let me just highlight it with another color so it's clear. All right. And now let's check if this is the correct answer. So I'm going to open up the marking scheme. All right, so the mark scheme says that it's 3x to the power 2 over 3 minus 3x to the power 4 over 3 over 4 plus 5. So, indeed, our answer is absolutely correct. So we would get, how many points is this question? So we would get 4 points. Right, let's move to question 2. Question 2 says, a curve has an equation y equals x squared plus 2cx plus 4. And a straight line has an equation y equals 4x plus c, where c is a constant. Find the set of values of c for which the curve and the line intersect at exactly 2 distinct points. So when we're reading the questions, we have to look for certain clues in the question. So the clue here is intersect at 2 distinct points, which means that when we equate the two equations, we will have, so let me just make a note. This means intersect at 2 distinct points. So this is 2 solutions. And what does 2 solutions mean? It means that the discriminant, which is b squared minus 4ac, is going to be more than 0. That is what we should pick up from the question. All right, so step 1. Equate. Okay, so let's equate. X squared plus 2cx plus 4 equals 4x plus c. Let's move things to the other side. So we have x squared plus 2cx minus 4x plus 4 minus c equals 0. So what we're doing here is, let's make a note, moving to the other side. All right? So now let's group common things. So we can do x squared, and then we can take x out. So we will have 2c, and then minus 4, and then plus 4 minus c. So we achieved an equation, achieved ax squared plus bx plus c. All right, that was step 1. Now we're going to do step 2, which is going to be make an inequality with b squared minus 4ac is more than this. All right, let me use another color. So that's step 1, and this is step 2. All right, so we have our a value, b value, and c value. So b squared is going to be 2c minus 4. So 2c minus 4 to the second power, and then minus 4, and our a is just 1, and our c is 4 minus c, and all of this is more than 0. All right, now let's expand things. So 2c minus 4 squared is going to be 4c squared minus 16c plus 16. And then this whole thing is going to be minus 16 plus 4c. And all of this is more than 0. And now let's combine common things. So we have a plus 16 and a minus 16, and these are just going to cancel out. And then we have a minus 16c and a plus 4c. So we're going to have minus 12c. So 4c squared minus 12c. All right. And now we will divide by 4. Divide by 4c. So we have a greatest common factor, which is 4c. So let's divide by 4c. We get c minus 3 is, yeah, we get 3. C minus 3 is more than 0. So c should be greater than 3. But we shouldn't forget one thing. So since we are dividing by 4c, so a lot of students forget this, what we're actually doing is taking 4c out of the bracket, basically. So what we're actually doing is, let's just go back to the question. So they say intersect at 2 distinct points. All right. So we should see that when we take, so our original thing is like this, yeah? 4c squared minus 12c, and then we divided by 4c. Is that right? So what we actually did is first we took 4c out of the brackets, and then we ended up with c minus 3. So this is basically what we did. And we should actually remember that we have the 4c2. So basically we are equating the bracket to 0, what we're doing basically. So we're doing c minus 3 equals 0, and then we're doing 4c equals to 0. And then we're getting c equals to 3 here, so we're saying c should be greater than 3. But we should also remember that here we also get c equals to 0. So we should do also c is less than 0, because we have a greater sign. A greater sign basically indicates that when we have two values, for example, let me show you visually. How do we set an inequality when we have two answers and the greater sign, like in the form b squared minus 4ac is greater than 0? So imagine you have a quadratic equation, and we're interested in the areas that are greater than 0. So we are basically interested in these areas. So this is greater than 0. By greater than 0, we mean that the y value is greater than 0. So the two answers that we got, let's say basically 3 and 0. So let's just assume that this is 3 and this is 0, because that's how it looks when we actually graph it. And this part is greater than 0. So we should take the part which is greater than the greater answer and less than the less answer. So the greater answer is 3, so we need to take the part which is more than 3. And the less answer is 0, so we need to take the part which is less than 0. That's why the set of values is basically going to be like this. So our answer is c less than 0, and then c greater than 3. So be very careful with this. A lot of people make a mistake and they lose 1 point. So don't be that person. All right. And let's confirm from the marking scheme. And yeah, indeed, that's the correct answer according to the marking scheme, or the mark scheme, how you call it. Now, let's move to the next question. All right. This is a binomial expansion question. So these can be quite hard, and these can take some time, but in such questions, my tip is to basically take your time, don't rush. So find the term independent of x in each of the following expansions. So we basically need to find some constant, not 3. Just why did 3 come to my mind? So we have some constant a, x raised to the power 0. So this is just going to be a. So we basically need to find x to the power 0 in the expansion. All right, let's try to expand. So if we actually expand, so step 1. So first we're going to expand, then we're going to observe. This is the slower but better method in my opinion. Some people can do it in their head, like put some values. This can be a method too. We can try to do that. We can try to do that too. So in the first expansion, we'll have 3x. So the 3x will have a power 6, and 2 over x squared will have a power 0, so that's not going to work. And then we're going to have 3x power 5, and that's not going to work either. And then we're going to have 3x power 4. Nope. 3x power 3 and 3. Nope. Let's just expand, because the first method, the doing in your head method, can be quite confusing for some people. So let's actually expand. So we have 6c0 multiplied by 3x to the power 6 multiplied by 2 over x squared to the power 0. Then we have 6c1 multiplied by 3x to the power 5 multiplied by 2 over x squared to the power 1. Then we have 6c2 to the power 3x to 3x to the power 4 multiplied by 2 over x squared to the power 2. All right, we achieved our first independent variable here. Well, independent term, basically. It's this one. Let me just correct this. Okay, it's this one, because we have 3x to the power 4, and then we have 4 over x to the power 4. So the x to the power 4s will just cancel out each other. All right, that's our first answer. Not answer, but first step solving the equation, kind of. Let's continue. 6c2, 3x to the power 3, and 2 over x squared to the power 3. All right, now the 2 over x squared values are just getting too large, and the 3x will just get too small. So the other values, oh, this is 63. So the other values basically won't work. So this is the only one that will work. Excuse my horrible star. All right. So we need to, okay, we observed. Now we just simplify. Let's simplify everything. So we have 6c2 multiplied by 3x to the power 4 multiplied by 2 over x squared to the power 2. So if we plug in 6c2 into our calculator, we will get 15, and then 3 to the power 4, that's 81. And then we have 4 over x squared. 4 over x to the power 4. Sorry for that. So x to the power 4 and x to the power 4 cancel out. So we're left with 15 multiplied by 81 multiplied by 4. And if we plug that in our calculator, we get 4,860. And let me check the marking scheme. All right, that's indeed the correct answer. So we solved this question correctly, this part correctly. Now we can move on. And now the B part is saying we are taking the original expansion and then we're multiplying that by 1 minus x to the power 3. And what we need to do is find the term independent of x. All right, how do we do this? So basically, we're taking this whole expansion and multiplying by this 1 minus x to the power cubed. Not to the power cubed, but 1 minus x cubed. So since we see a 1 there, we know that we can use our initial value, which is 4,860, because that's just going to be multiplied by 1, basically. And now we have x to the power 3. So we're going to multiply something by x to the power 3. So from our original expansion, we need to find something, let's call it a over x cubed, so that when we multiply it by x cubed, we just get an independent term, which doesn't have an x value. So we need to find something divided by x cubed in our original expansion. Right, let's check out what we have so far. So is this going to be something divided by x cubed? So I'm looking at this one specifically, just for reference. So, okay, we have an x cubed, and then we're going to divide it by x to the power of 6. And that is actually going to give us x to the power of minus 3, basically. Exactly what we need. But let's just check if the next term in the expansion is going to work too. So we're going to have 64 multiplied by 3x squared multiplied by 2 over x squared to the power 4. So we're going to have an x squared and an x to the power minus 8, and that will give us x to the power minus 6. So that's not going to work. So indeed, this one is the only one that's going to work. So 63, 3x to the power 3, and then 2 over x squared to the power 3. So that's what we're going to use. So 63, 3x to the power 3, 2 over x squared to the power 3. And let's expand this. So 63 is just going to be 20 multiplied by 3 to the power 3, that's 27, x cubed. Then we're going to multiply it by 8 over x to the power 6. So x3 and x6 will cancel out, and this will be x3 now. So all of this will give us, let's see, 20 multiplied by 27 multiplied by 8, 4320 x to the power minus 3, basically. All right, now we have our values. So now we have 4860, and then we have plus 4320 x to the power of 3, x to the power minus 3. Then we're multiplying that by 1 minus x to the power 3. All right, so this is just going to be a simple multiplication. So basically, it's like this multiplied by this, and then that, and then this, and then that. But I guess you know that already. So actually, we don't need to multiply everything by everything. We're just going to multiply 4860 by 1, and we get 4860. And then we're going to multiply 4320 x to the power minus 3 by minus x to the power 3. And we're going to get minus 4320. And if we plug that in our calculator, we're going to get, let's see, 4860. We get 540. And let's check if that's the correct answer from the mark scheme. All right, and the mark scheme says that that's indeed the correct answer. Okay, let's look at question 4. Sorry, okay. Okay, so this is a 6-mark question. It can be quite hard, but let's see what we can do. The first term of a geometric progression. So let's just highlight key details. Geometric progression and the first term of an arithmetic progression are both equal to a. So this is our first piece of information. So let's just note this down. So the first term of a geometric progression, let's call it a. No, we have an a already. Let's call it c. That equals, no, let's call it x actually. That's better. So we have x equals to a, and then that's the first term of the geometric progression, and the first term of the arithmetic progression is going to be also a. So from that we obtain that x equals to a y. Okay. The third term of the geometric progression, so that's the second piece of information that we'll note down. Third term is equal to the second term. So the third term of the geometric progression is equal to the second term of the arithmetic progression. So what do they mean by the third term? We're basically taking and multiplying by some constant twice. So it's going to be x multiplied by r squared. R is the constant. And that's going to be equal to the second term of the arithmetic progression. So we're basically taking the first term and then adding some constant. So let's say it's y plus d. But we know that x equals to y, so let's just narrow it down, and let's say xr squared equals to x plus d. That will be way simpler. The fifth term of the geometric, okay, this is the third information. The fifth term of the geometric progression is equal to the sixth term of the arithmetic progression. All right, this is the third information. The fifth term of the geometric means that we're multiplying by some constant 5 times. Oh, no, 4 times. Sorry for that. This is the fifth term. All right. Is equal to the sixth term of the arithmetic. So we're taking the first value, which is x, and then we're adding some constant 5 times. So it's going to be plus 5t. Okay. Given that the terms are all positive and not all equal, find the sum of the first. Oh my god. So that's what we should find. The sum of the first 20 terms of the arithmetic progression in terms of a. Okay. So first, let's identify what we need to find. Find sum of first 20 terms of arithmetic progression. Okay, so let me just open up a formula sheet. So AS and level formula sheet. So you'll be provided with a formula sheet which has the formula for the sum of an arithmetic series. Okay, so we have the formula for the sum, which is going to be, okay, which is going to be Sn, so sum of first n terms. It's going to be n over 2 multiplied by 2a plus n minus 1 multiplied by the common difference d. So a is the first term, which is our x or y, and n in this case is going to be 20 because we need to find the sum of first 20 terms. So it's going to be 20 over 2, which is just 10, 2a plus n minus 1 is just going to be 19, and then d. And we need to find all of this in terms of a. So we need to get rid of the d somehow. And how do we get rid of the d? We basically, we have to look at part 2 and part 3 from our original stuff. So from part 2, we found out that xr squared equals x plus d. And from part 3, we found that xr to the power 4 equals x plus 5t. Okay, how's that gonna help us? Let's see, let's think. Let's think, how will that help us? Well, what if we try subtracting stuff? Let's say xr4 minus xr squared, and that will be x plus 5d minus x plus d, which is gonna be just 4d, and this will just equal to xr squared r squared minus 1. So we found out that xr squared, r squared minus 1 equals 4d. Okay, but we have xr squared. Xr squared is x plus d. So this equals to x plus d multiplied by r squared minus 1. Does that give us something? I'm not sure. Let's think and think. Maybe there are different ways. This didn't necessarily give us something. Xr squared is x plus d, and xr to the power 4 is x plus 5t. And I'm pretty sure that's correct. Well, x is just a, just to say that. So we need t in terms of a, basically. So to make things more simple, let's say ar squared equals a plus d, and ar to the power 4 equals a plus 5t. All right, this should make things much simpler. What can we actually achieve by doing this? I'm just thinking out loud. Usually these types of questions, like this, some kind of question, I usually like skip it if I'm stuck and then come back to it later, because when I'm stuck at a question, I'll just spend too much time thinking on it, and then I'll just forget about the other questions. So it might be a good practice to actually try to skip it and come back to it later. But for some reason, I don't want to do that. For some reason. So ar squared minus a equals to d. All right, and now we have this. Now we can substitute that. So a plus 5d is basically going to be a plus 5 ar squared minus a, which is a plus 5 ar squared minus 5a, which is 5ar squared minus 4a. All right, does that give us something? And that's a plus 5d. So this is equal to xr to the power 4, or ar to the power 4. We changed it actually. So ar to the power 4 equals to 5ar squared minus 4a. And now we can divide by a and see if that helps us. Let's see if that helps us. Let's divide by a. So we have r4 equals to 5r squared minus 4. All right, so we're achieving a quadratic equation for r. Okay, and now let's move things to the other side. So we have r4 minus 5r squared plus 4 equals to 0. And now let's set r squared equal to, what can we set it equal to? Just to make things simple. We have an a, we have an x, we have a y already. What else do we have? Let's just set it to like beta, like the most random thing. So r squared is beta. So we have, so this gives us beta squared minus 5 beta plus 4 equal to 0. And we can actually simplify this. So this is going to be beta minus 4 multiplied by beta minus 1, giving us 0. So beta 1 equals to 2, and beta 2 equals to 1. So these are our two answers for beta. And we should remember that r squared is beta. So we have four answers for r basically. So we have r1 equals to 2, we have r2 equals to minus 2, we have r3 equals to 1, and r3 equals to negative 1, I guess. Yeah, is that how it is? Yeah, I guess. Sometimes I can go too far and then notice that I did a mistake only at the end when I have no time left. So we're running out of space actually, so we need to simplify things down quite quickly. And then what do they say in the question? I think they mentioned about something. Given that all terms are all positive and not all equal, find the sum of the first 20 terms of the arithmetic progression. Okay, so they say that the all terms are positive. So we cannot multiply by negative because we're going to get a negative term. So r is, we can simplify r to be 2 and r to be 1. All right, so we got rid of the negative answers. And now what we can do, so we have r, and now we know that we can actually plug that in. So we have ar squared equals a plus d. So ar squared equals a plus d, and we found that r is either 2 or 1. Well, 1 actually shouldn't work because if the term is just going to be 1, then every single term of the geometric sequence will just be the same thing because we're multiplying by 1 over and over again. So we actually further simplified it to just this, r equals to 2. All right, so ar squared equals a plus d. So is that what it is? Yeah. Ar squared equals a plus d. Okay. And this will give us 4a equals a plus d. So 3a equals to d. Wow. All right, we have a lot of things now. So let me just delete all of the unnecessary things and leave 3a equals to d, where we found earlier. All right, we have 3a equals to d. So we finally found a d in terms of a, which was our main goal. And now we can plug it in our sum equation. So s20 equals 10 multiplied by 2a plus 19 multiplied by d, which is 3a. This is going to be 10 multiplied by 2a plus 57. Is that right? Yeah, plus 57a, which will give us 10 multiplied by 59a, which is 598. So that should be our final answer. So final answer equals 598. And after long, I don't know, 5 minutes, 10 minutes, I don't know, we finally achieved an answer, and let's see if that's the correct answer. And yeah, 598 is indeed the correct answer to this question. That's wonderful. So now let's skip to the next part. So this was question 4. Now question 5. So we have a functions question, I guess, or something like that. I'm not sure. So question 5a. Express 2x squared minus 8x plus 14 in the form. All right, so basically they're just asking us to complete the square, I guess. So complete the square. That's just what this question is asking for in a nutshell. So how do we complete the square? First, we take out the coefficient of x squared, which is 2. So we're going to have x squared minus 4x plus 7. And now we divide the coefficient of x with 2. So negative 4 divided by 2 is going to be negative 2. So we're going to have x minus 2 squared. X minus 2 squared. And then we have our plus 7. And then when we're going to expand x minus 2, so let me just show you. So when we expand x minus 2 squared, we're basically going to get x squared minus 4x plus 4. So we have this unnecessary 4 here. So we need to get rid of that here, and in order to do that, we subtract 4, which will give us 2x minus 2 squared, or no, that's not the form they asked. So it's going to be like x minus 2 squared plus 3. Yeah, so that's basically what they asked for. And that's indeed the correct answer, according to the marking scheme. Or the mark scheme, I don't know. So now we move to the B part. The functions f and g are defined by this and that. Describe fully a sequence of transformations that map the graph of y equals f of x onto the graph of y equals g of x, making clear the order in which transformations are applied. So usually the order is first, like, I guess the order doesn't really matter. You just have to say like number 1 and number 2, and that's it. In some cases, the order matters. So let's see. We have f of x equal to x squared. And then we have g of x equals to 2x squared minus 8x plus 14. So the thing is that when we are dealing with questions which ask like maps the function of this to the function of that, and we need to describe the order of transformation, usually we deal with the completed square form or the vector form. That's why usually they ask that in the A part, and then they ask us to tell the sequence in the B part. So basically g of x is this, what we have here. So that's g of x equals to 2 multiplied by x minus 2 squared plus 3. That's basically our g of x. And now we need to map f of x into g of x. So what is the first thing that we can notice? So we can notice that instead of x squared, we have x minus 2 squared. So in the bracket, we're going to have x minus 2, because that would give us x minus 2 squared. The first thing that we're working with, that's step 1. And then step 2 is how do we transform x minus 2 squared into x minus 2 squared plus 3. So we basically add 3 to the equation, to the function. And that would give us x minus 2 squared plus 3. And what we performed here is a translation. And translations are usually one sequence of transformation. So this is one thing. So when we add some number into the function itself, like f of x, or we do f of x minus 2, so inside the brackets themselves, so any number that's inside the bracket itself is going to be a translation on the x-axis, and usually the reverse of what's inside. So we have a x minus 2, so we're translating by 2 on the x-axis, so by 2 to the right. And we usually express this in a column format, so we have a plus 2 here, and then we have a plus 3. Plus 3, usually everything that is like added or subtracted that is not inside the bracket but outside is a transformation on the x-axis, on the y-axis. So this is going to be on the bottom. So in a column vector format, what's above is a transformation on the x-axis, and what's below is a transformation on the y-axis. So this is one transformation, one sequence. That's a translation, basically. And now we can see that this whole thing is basically multiplied by 3. Oh my god, what just happened? Okay. So how do we turn from this to this? The only thing that's left is to multiply this whole thing by 2. Yeah. And what is a multiplication by 2? That's outside. So not inside the brackets, but outside of the whole equation. That's a stretch on the y-axis. And the scale factor is basically just the number that we're multiplying with. So since we're multiplying by 2, this is going to be stretch by a factor of 2 on the y-axis. So our full set of transformations is translation 2, 3, and then stretch by factor 2 on the y-axis. So that is our answer. And let me just check if that's indeed the correct answer. And yep, that is indeed the correct answer. And basically the order matters, because if first you would say that it's a stretch, then the translation would basically be different because you already stretched it. So you need to have a different type of transformation. So if you first stretch it, then you will have to translate on the y-axis not by 3, but by 6, since we stretched it by a factor of 2. But in our case, we first translated it, then stretched it, so everything's fine. All right. This is question 6. So let's look at question 6. The circle with the equation x plus 1 squared plus y minus 2 squared. So this is the equation of the circle. And what did we find out from it? The first piece of information. The center of the circle is -1 and 2. And the radius of the circle is square root of 85. And a straight line with the equation y equals 3x minus 20 are shown in the diagram. The line intersects the circle at A and B, and the center of the circle is at C. Find by calculation the coordinates of A and B. All right. So usually in these types of question, we basically just take this, which is the equation of the line, and we just straight up put it into the circle equation. So we're gonna have something like x plus 1 squared plus y. So instead of y, we're gonna put 3x minus 20, and then minus 2 squared equals 85. All right? That will transform everything into, if we just expand, x squared plus 2x plus 1. And then in the brackets, we're going to have 3x minus 22. So it's going to be plus 9x squared. And then 3x minus 22. So it's going to be 22 multiplied by 2 multiplied by 3, which is negative 132x. And then we have negative 22 squared, which is plus 484. And all of this equals to 85. Let's simplify things. So we have an x squared and a plus 9x squared, so that's a 10x squared plus 2x minus 132x, so that's a minus 130x, plus 1 plus 484, that's plus 485. And then we have a 85 on the other side, and let's bring it to the other side now. And this equals 0. So we achieved ax squared plus bx plus c. And now let's simplify things. 10x squared minus 130x plus 400, that equals to 0. All right, now we have a equation, a polynomial, basically, in the form ax squared plus bx plus c. And how do we solve those? We use either the quadratic equation or we just factor it out. So first of all, let's get rid of greatest common factors. I can see that we can divide by 10. So we're going to get x squared minus 13x plus 40. And now let me think for a moment if we can actually, yeah, we can factor this out. So it's going to be x minus 8 and x minus 5, which equals to 0. So if you don't know how I actually factored this, soon I'm going to upload a video showing how to factor trinomials. So this is basically what we get. So our two answers are x1 equals to 8 and x2 equals to 5. So these are our two coordinates. So if we just look back at the equation, we will know that this is x equals to 8 and this is x equals to 5. And now we should just find the y coordinates by plugging in into 3x minus 12. So 3, 8 minus 12 is going to be 24 minus 12, which is just 4. And 3, 5 minus, not 12, but 20, sorry. So 15 minus 20, and that will be negative 5. So our values are 8 and 4. So 0.1, let's say. 0.1 is 8 and 4. And 0.2 is 5 and negative 5. And that should be our answer. And let me check. 8, 4, 5, negative 5. Yep, and that's completely correct. All right, so we're gonna finish by solving 6b, and it's gonna be the end of part 1 of this paper. So in order to not make it too long, I'll break it down into two parts. Find an equation of the circle which has its center at C. So the center at C. And what was the center C? It was minus 1 and 2. So C is minus 1 and 2. And for which the line with the equation is tangent to the circle. So we should basically make it tangent to the circle. What do we mean by tangent? We mean that it should actually touch the x-axis, not cross it. It should only touch it once. So what do we mean by that? What do we mean by tangent? Tangent is a key word in vector geometry. So whenever you see tangent, you know you're going to be dealing with answers to the equations. Tangent means one answer when we equate, which is when the discriminant is 0. So we need to equate the discriminant to 0, basically. So we have some equation of what it is. Find the equation of a circle. So some circle, and we don't know the radius, so let's just call it C. And we should equate it to y equals to 3x minus 20. And then we should basically make the discriminant 0. So from our first question, when we solved it, we know that we are going to get 10x squared minus 130x plus 485. So 10x squared minus 130x plus 485. And then this equals to c, so we're just going to do minus c equals to 0. All right? And now b squared minus 4ac equals to 0. So our b is negative 130. That's squared. A is 10, and c is 485 minus c. And this whole thing equals to 0. All right. So from this, so let's do 130 squared. That equals to 16,900. And this should equal to, so I'm basically taking things to the other side of the equation. So negative 40, so 40 multiplied by 485. Negative, okay, so this is going to be as 19. And then we have minus 40c, I think. Let me just see if I did everything correctly. So originally this is going to be a minus, so we move it to the other side and we get a plus, and the other one will originally be a plus. Yeah, minus 40 multiplied by minus c plus 40. Yeah, so that's correct. So from this, we can find out that 40c is actually 19,400 minus 16,900, which is 2,500. So c is going to be 2,500 divided by 40, which is 62.5. So we got c equals to 62.5. So the equation of the circle should basically be x minus 1 squared plus y, oh, not x minus 1, x plus 1 squared minus y minus 2 squared equals 62.5. But I'm not sure about this, but let's see if that's actually correct. Let me just check the mark scheme. And yeah, that's indeed correct. So we solved this question correctly. All right, thanks for watching. This is the end of part 1, and I'm gonna link part 2, so you can just continue watching.